Hello, my name is Tian Li, and we are Team 6. Today, we are going to present you about the predictive data analysis of Paycheck Protection Program from U.S. Small Business Administration. Our presentation consists of three parts: background and data mining methodology and result, and conclusion. First, I will talk about the background of Paycheck Protection Program and describe the data set we used in the research. The Paycheck Protection Program, PPP, is a $953 billion business loan program established by the United States federal government to help certain businesses and their workers. It is uncollateralized funding with potential of full amount of forgiveness. Our data is focusing on the third wave of applications, opens December 27, 2020. There are three numerical variables, non-categorical variables, and 10,000 lines of Georgia application data in total, which is collected from both removed and unremoved pool of application. Here are some interesting findings in our data exploration. First, we found that some indicators have different amount of approval rate. They represent if the business have some kind of character, whether a business is in help zone program, low to moderate income, or in rural area. Second, we found that number of loans approved are related to the date and especially high in May 2021. Next, let's look at our research target.
Okay, now let me introduce the target of our project. Based on the data set we mentioned before, we want to explore the following three questions. The first one is to find the important features which may influence the applications would be removed or not. We try to answer this question by interpreting the coefficients in the logistic regression model, to compare the significant level and the p-values for each variable. Besides, we will conduct a lasso regression model to choose the best lambda value and to do the feature selection. Also, we will visualize the feature importance when conducting bagging and XG boosting models. In addition, we are the most interested in which model performs the best among all the 6 supervising learning methods we conduct. We will run 2 regression models, including logistic regression and lasso regression, 2 tree models, which are classification tree and random forest, and 2 boosting methods, which are gradient boosting and XG boosting. For each model, we will use 70% of data to train a model, and then based on the training model and the other 30% of data, we will make a prediction and calculate the accuracy on the test data set. Finally, we will decide which model is the best based on the test data set accuracy. Lastly, as we know, things are changing every day. So we also want to discuss whether our best model is good or stable enough to be applied in the next long application scenarios. Especially, when something changes, such as a policy. And in the real world, the unbalanced data is also a critical issue, which means the number of unremoved applications is far greater than the number of removed applications. By discussing this, we hope that we can put forward the further improvement of our models and the future work we can do.
Well, thanks for Xinyuan. In the part 2, we will talk about 4 supervised models and 2 unsupervised models and their results. So first, we choose the logistic regression model to build our baseline, since this is the most common model to explain and predict. The accuracy is 64%, and these variables are statistically significant to our model. But the AIC is very high, which means that the model does not fit very good. And we wonder it's because there's too many variables. Then we try to deal with this by the lasso regression. In the lasso regression model, the best lambda equals to 0.0138, so that the shrinkage penalty is meaningless. and the accuracy is lower than the full model. So we conclude that the feature selection was not necessary. And since the model are not performance good before, we want to try the classification tree. The accuracy of the classification tree is 72.7%, much better than before. And after we prune it, the model is like this. We can easily explain like the applications was in the hub zone and late then the begin day over 142 days will easily to be removed. And we can conclude that in the tree models, different days, hub zone indicator, and loan amount are the most powerful predictors. In our case, the data is not very noisy, so we suppose the random forest will perform almost like the classification tree. And I will pass the next part boosting to Zihan.
Thanks to Jie, boosting has been called the best of the shelf classifier in the world. In our project, we tried gradient boosting and XG boosting. In both boosting models, we use cross-validation to decide the iteration. Here, we show the parameters and the feature importance. As you can see in gradient boosting, the top three important features are data approved, NACES code, and the congressional district, which is a little bit different from the result of random forest. We believe that the probability of a loan being rejected is related to the length of time between the start of PPP program. So here we treat the data approved as a time period from the start. Well, in the extreme gradient boosting, so-called XG boosting, we have first transformed the data into sparse matrix and then fit the model. The top three important features here are data approved, long amount, and the hub zone, totally same with the random forest. Our result shows that the XG boosting is indeed an improvement of gradient boosting. Here shows the ROC curve. We use the best cutoff in the validation dataset. The accuracy of XG boosting is higher than the GBDT. In total, we tried 6 supervised models. We also use the cross-validation and the feature selection to improve the model. All in all, XG boosting has the best performance in terms of accuracy. But actually for this dataset, the difference between the tree and the boosting is not very big. In addition, we found because we only have 13 variables, to get a higher accuracy, the feature selection may not be necessary. To improve the accuracy, we may need more information, such as the credit history and the financial status of the company. Besides the supervised models, we also tried 2 kinds of unsupervised methods. Now let's welcome Su Yu to give the final part.
Hi, now I will start talking about the unsupervised models that we used for this project. We use clustering, and we first started with the elbow method to determine the optimal number of clusters, which is 8. And we see the output here on the left side that there are almost similar output for not removed and removed results in almost every cluster, and which is not good enough for us to draw conclusions. And it'd be difficult to extract the characteristics of removed applications by this method. Then we use association rules. From the result, we can see the lift ratio is around 1.55 for almost all the top 5 rules, and data bins and hub zone indicators are highly related to the consequence of removed. So between these 2 methods, we can say that association rule is better than clustering. For conclusions, we have conducted a comprehensive assessment using supervised models and unsupervised models. We can conclude that important features for this classification application are different days, the difference of number of days between data approved and 2020, December 27. And the second one is loan amount, and the third one is hub zone indicator. The best model with highest accuracy in this data set is XG boosting. The prediction for next loan application scenarios using the best model is unstable if the policy changes because of the unbalanced data in the real world and many other complicated factors. Some remedies for this problem could be using other models like light GBM or encode more information on COVID-19. And that is all we have. Thank you so much for your time.